Hello everyone, Dana here from Dana's Electrical Services, and in today's video I will be going through how to read a breaker rating. So we will just jump right into this video. So the first thing, what is a breaker? So according to my definition, a breaker is a device that is used to automatically interrupt an electrical circuit in the event that there is a fault. And this is done in an effort to protect wires and appliances from damage. So most breakers, they detect faults such as overcurrent or short circuit. And there are also some other types of breakers like residual current device that protect against leakage current. So one of the first things we want to talk about as it relates to the rating of a breaker is the rated current and the interrupting ratings, right? So first, before I show you what those are, let me tell you what those are which is kind of weird what I said. Anyways, so first I'll be going through the interrupting rating. So as it relates to the interrupting rating, this is the maximum amount of current that the breaker can safely interrupt without being damaged. So if you have this breaker, right, and it has an interrupting rating, you see the interrupting rating there of 10 kiloamp, that 10 kA that you see right there, that is the interrupting rating. And the most common interrupting ratings are between 5,000 to 10,000 amps. So if it has an interrupting rating of 10 kiloamp, right, and a current of, let's say, 15 kiloamp or 15,000 amps pass through it, there's a high possibility that this breaker will be damaged before it can safely interrupt the circuit, right? So that is what the interrupting rating says about the breaker. And if you look on this one right here, it has an interrupting rating of 6,000 amp. If you can see that, 6,000 amp. This one has an interrupting rating also of 6,000 amp. And I think all the plug-in breakers down here has an interrupting rating of 10,000 amp, right? So again, the interrupting rating is the maximum amount of current that the breaker can safely interrupt without being damaged. And the most common interrupting ratings and breakers are between 5,000 to 10,000 amps, right? So it can safely interrupt the circuit if the current is below that value, right? So I hope you guys understand that. The next thing we will go through is the rated current. And the rated current is the current value that the breaker will allow to pass through it without interrupting the circuit unless the value is exceeded, right? For instance, on this one, this 15 amp breaker right here, the rated current is 15 amp, right? This one is 20, and we have a double pole 20 amp right here, we have a double pole 50 amp right here, and I'll soon get through to the other one in a minute or in a few seconds, right? So again, this is the current value that the breaker will allow to pass through it without interrupting the circuit unless the value is exceeded, right? But that doesn't mean that if I have this 20 amp breaker and the current and the load changes to 21 amps, it is going to instantly trip. No, that is not the case. And this is where these come in, right? So you notice on this breaker, you see D63, and this one you see C63. So what does these letter value represent, or these letter rating represent? Because you're gonna see D, you're gonna see C, or you might see D, and in some less common instances you might see K and Z. But the most common ones are B, C, and D. As you see, I have a D here, I have a D here, and I have a C here. right? So the letter rating indicates the instantaneous tripping current that causes the circuit breaker to trip without intentional time delay. I think I want to say that one more time, right? The letter rating indicates the instantaneous tripping current that causes the circuit breaker to trip without intentional time delay. And there is a curve, right? So there is a tripping curve for circuit breakers, and that shows you, based on the letter rating, how much the current has to exceed the rated current before it will trip, and how long it will take to trip. So we have, as I said, we have B, C, and D. So for B, it has to exceed the rated current by 3 to 5, between 3 to 5, right? 3 being the minimum value and 5 being the maximum value. By the way, this is 3 to 5 times the rated current. So for instance, I have this 20 amp breaker, right? Before this breaker can trip, it has to exceed the rated current by 3 to 5 times. So 3 times 20, that is 60. 5 times 20, that is 100. So in order for this 20 amp breaker to trip instantaneously, it has to exceed this rated value, which is 20 amp. It has to exceed it by 60 to it has to be 60 to 100 amp before it can trip, right? And if you look at the diagram, if you look at the graph right here on screen, you will see if it exceeds it by 3 times the rated value, and if you go up on that graph there, you see that it takes what? A little below 10 seconds to trip, right? If it exceeds it by 5 times the rated current, so if the amp rises to, so if the amperage is 100, it will take 1 second to trip, right? Alright, so if I should be more precise, right? If I have this 20 amp breaker and it is a B type, so if the current is 100 amp, right, and it is rated at 20 as we see here, if it is at 100, it is 5 times the rated current, so it will take 1 second to trip the breaker, right? And if the current is, let's say, 60, which is 3 times the rated current, it will take, initially I said about 10 seconds, but it actually would be less. So let's say about 7 to 8 seconds, somewhere there about, somewhere between 5 and 10. So between 7 to 8 seconds to trip that breaker, right? And if it does exceed it by a small amount, it will trip at some point, but not instantaneously. The reason for this is because sometimes we have appliances or we have devices that have surge in them. For instance, let's say you have a motor, right? And your motor is rated at, let's say, 10 amp, right? And you have it and it's 20 amp breaker. But on starting, your motor might rise to like 3 times the rated current. So the motor is 10 amp, right? So you can safely protect it with a 20 amp breaker, right? But guess what? On starting, the motor current rises to 3 times the rated current. So even though the motor is rated at 10 amps, on starting, the motor pulls a current of 30 amps, right? But it does that just on starting, for literally for like a few seconds or a few milliseconds, right? And then it goes back down to its rated current. So you don't want it to be a case where your breaker trips instantaneously, right? Your breaker trip instantaneously when you have a small surge like that or a small spike like that, right? Hence why the breaker has the letter rating to alleviate this issue, right? So as I said, we have B, C, and D letter rating. C trip between 5 to 10 times the rated current. D trips between 10 to 14 times the rated current. And you have the less common ones like the K and the Z. K is between 8 to 12 times, but this is for loads that cause frequent short peaks, short current peaks. So for some load, probably that is similar to the motors, but it is more frequent, not only on starting. So you have frequent short current peaks under normal operation. You'll use a K-type circuit breaker. And then you have the Z-type, which trips between 2 to 3 times. And you mostly use this for loads such as semiconductor devices, loads that are semiconductor devices. So yeah, that should sum it up. That pretty much tells you what you need to know as it relates to the current rating. But you're gonna also see some other things on your breaker, like temperature. Yeah, some of them has the temperature rating on it. So if you can see on this one, again you see the 50, 60 hertz, right? This one is 10,000 amp, and that is the interrupting rating. This one tells you the wire size and the temperature, so you have to use a certain temperature wire. So this one says 60/75 degrees Celsius, and the type of wire, whether it is aluminum or copper. Also it tells you the pressure that the lug can manage. This one is 45 pounds. Yep. And you'll also see the voltage rating. So this one is 120/240. So that is the line voltage, the safe or the rated line voltage to pass through this breaker. So all of these plug-in breakers that you see down here, these are 120/240 volts. These DIN rail breakers, however, 400 volts AC. These are 50 hertz frequency. Yeah, this one is 400 volts also. This means that 400 volts can safely pass through each line. So you have one line here. This is a residual current circuit breaker, by the way, or RCBO, which is the residual current circuit breaker with overcurrent protection. This is a regular MCB, miniature circuit breaker. So this means that 400 volts can pass through each leg, right? This one was burnt up. This is a bad breaker that I'm doing my demonstration with. So yeah, 400 volts can pass through each leg. What else? As I said, this one is 50 hertz. This is also 50 hertz. These ones are they are both 50 and 60 hertz, I think. Don't quite remember. Yeah, there it is, 50 and 60 hertz. So that is what you need to know as it relates to reading a breaker rating. If I missed anything and you like any clarification on anything, please leave a comment down below and I'll get back to you as soon as possible. Right? So this was another video brought to you by Daniels Electrical Services. For more videos like these, please feel free to subscribe to my channel at Daniels Electrical Services. Thank you. Let's jump in and I hear my name.